Another very common theme in functional programming languages is the use of recursion. And you might actually wonder some about the existence of lists and why you should care about these immutable lists. Turns out that they work really well with recursion, both for processing and for building. And it's possible that in your previous programming experience you haven't really worked with recursion much, so it's worth spending a video to talk about how you can write recursive functions that deal with lists. So there are two types of things that we could do here. One is we could have a function that is used to build a list. And let's say we wanted to build a list from user input, for example. So I want to make a method build list, and because it's going to come from user input, I'm not going to pass any arguments in. It's going to be a list. We will go with strings. And what I want to do here is I want to read from the user. So now input equals read line. And then I want to check. If the user types in quit, we're going to stop. If input is quit, then I want to give them back an empty list. Okay, so you can imagine we've called this, they type in quit, I'm going to give them back no list at all. Now I can say an empty list like that, but there's also a name for the empty list that we will use. It's called nil. Notice it has a capital L there. And then we can say else. Well, what if the input isn't quit? Then I want to take that input and I want to give it back const onto the result of calling build list again. So that we can show how this works, let's go ahead and say val lst equals build list println lst. We can run that. Now it's still asking us, for example, for our name and our age. Okay, now it's asking us for just words, whatever. I didn't give it any prompts, so you can't really tell what it's asking, but I typed in this is a test. And then I typed in quit, and so we get back that list. So here we're using cons in a recursive function to build up a list. All recursive functions need a base case, so our base case here is nil. We've gotten to the end of the input, and we just want to return an empty list. And then at each time through, it winds up adding an element to the beginning of the list that is kind of the rest of the list. So you should think of it as this element const onto the rest of the list. And at the end, the rest of the list is just an empty list. So that's an example of how you can use cons and a recursive function to put together a list. What about going through and, for example, just running through elements? Something that we might want to do might be, so summing a list of strings. Turns out you can't call sum on the string type. This is something you could do with reduce, but I want to write a method called concat strings, which takes a list of string. Actually, how about we call it words? And it is going to return to us just a single string. Okay. Well, there are basically two possibilities we want to think of for words as far as our recursive function goes. One is it's empty, in which case we would return an empty string. Otherwise, there is a word there, in which case I should take that word and concatenate it on. Obviously, concat string could also be done with mk string, but we want to see how it works recursively. We're going to write this first using an if. So we're going to say if words.non-empty. So if there's something there, or actually no, first let's do words is empty. Words is empty. If it's empty, we're going to give back an empty string. Else, we're going to give back the first element, which remember we can get by calling head, plus concat strings with the rest of the elements, which we can get by calling tail. So this is perfectly happy code, and we could illustrate this by calling print line of concat strings of lst. We'll print that instead of what we had before. Now, of course, this is just going to take whatever strings we put in and make a single long string out of them. If we run this, so let's input some things there, and then let's do again, this is a test, quit, and it prints out the concatenated. So concat strings concatenates things together. This is using kind of a standard style with an if. To get the first element, we're calling head. To get the other elements, we're calling tail. This is all very efficient to do with a list, but there's an alternate way that it's often expressed using patterns. Now, patterns can be used in a number of different places and ways. We saw them, we talked about them a little bit in the match. Turns out you can also put patterns in a val declaration. So this is kind of the simplest pattern of just a variable name, but I could use some other pattern if I wanted. There is also, it turns out that your for loops, the thing before the n arrow on a generator is a pattern. We'll talk more about that later because that winds up being very helpful in a number of situations. Lists and arrays can be used in patterns. So, for example, here's just a simple thing. Array, we'll just say ABC equals 1, 2, 3 dot split on a space. Okay, so hopefully you can tell what this should do. It's going to take 1, 2, 3, it's going to split them on spaces, which means we're going to get an array with 3 elements, and it's actually going to store those in the variables a, b, and c. Now, if this string didn't have 3 separate values that were separated by spaces, if the result was not an array of length 3, this would crash, and that would be a problem. So you don't, unless you really know what's going to come out from this, you often don't want to do pattern matching quite of this form. You can do the same thing with lists. If we had a function that produced a list, we could say list and then give it arguments, but that's still not all that general. Turns out you can also do pattern matching using what looks like the cons operator. And so we're going to write a second version of concat strings, and we're going to call it concat strings pat, or pattern. And we're going to use a match statement here. We're going to match on words, because the entire body is going to be this one match. I'm just going to put it here after the equal sign and not put an extra set of curly braces. So instead of having an if and an else here, I need cases. So one case is, well, it's empty. As we saw, we can call the empty list by its name nil. So that's our base case here. The other case can be expressed as a pattern that involves a cons. And we are going to write that as h cons t. H for head, t for tail. And then instead of saying words.head, I say h, and instead of saying words.tail, I say t. And so you can build up these patterns of lists, and I'm not just limited to 2, I could have 3 or 4 or 5. The last thing will always be the tail for whatever part of the list is left. Everything before that will be individual elements, and so you can recurse on the tail in these types of recursive functions. This does exactly the same thing as the concat strings, but it's often more common to see, instead of doing ifs, to use pattern matching for pulling apart the strings. So we've talked about lists, we've talked about how lists are used in recursive functions, we've written 3 different recursive functions that play with lists, and we talked about how you can use patterns with both lists and arrays, either kind of the less flexible form or in the case of lists, the more flexible form that uses the cons.